The search for Earth 2.0. The cosmic symphony begins. Imagine the universe as a grand orchestra, where stars, planets, and moons play in perfect harmony, a vast, celestial symphony unfolding across the fabric of space and time. Every glowing star is a violin string, every orbiting moon a drumbeat, every swirling galaxy a movement in an endless cosmic composition. But within this breathtaking harmony, there exists a mysterious section of the orchestra, one that has puzzled scientists for generations: the exoplanets. These aren't just planets orbiting other stars. They're possible worlds. Hidden in the shadows of distant suns, they stretch across the galaxy in numbers too vast to truly grasp. Worlds that might have oceans, mountains, storms, and skies of unfamiliar colors. Worlds that might, just might, harbor life. One such world has captivated astronomers and sparked a scientific obsession: Proxima B, a potentially habitable planet just 4.2 light-years away, orbiting the red dwarf star Proxima Centauri. In a galaxy that spans over 100,000 light-years in diameter and holds more than a quadrillion exoplanets, finding one so close to us and so tantalizingly Earth-like feels like discovering a cosmic message in a bottle floating just offshore. To put that in perspective, if each of those quadrillion exoplanets were the size of a grain of sand, we could fill not only the Grand Canyon but create a second canyon, a Grand Canyon 2.0 that stretches for miles, perhaps even reshaping the face of Earth itself. And astonishingly, around 20% of these planets are estimated to be Earth-like in terms of atmosphere and geology. That's 1 in 5. A staggering statistic that suggests our universe may be brimming with life-supporting worlds, each a stage for a drama we've only begun to imagine. Alongside them are moons, trillions of them circling like celestial dancers. Some might be rocky like our own moon, others icy or volcanic. Each is a candidate in the search for alien life, each one adding new layers to the tapestry of cosmic possibility. But how do we find these hidden gems? How do we explore places so distant that no spacecraft has ever come close? We rely on our eyes in the sky. Or more accurately, the James Webb Space Telescope, humanity's most powerful and ambitious window into the universe. Webb is not just a telescope. It's a cosmic lab, a forensic analyzer, and a time machine, capable of peering back billions of years and billions of light-years away. With its 6.5-meter golden mirror, Webb can detect the faintest flickers of light from distant stars and planets. Its infrared vision allows it to see through clouds of cosmic dust, revealing secrets the Hubble Space Telescope could only dream of. What sets Webb apart isn't just its power to observe, it's its ability to analyze. Through tools like spectrographs, it breaks down light into its individual components, like a prism revealing a hidden rainbow. Each element, oxygen, carbon, water vapor, methane, leaves a unique fingerprint in light. By studying these patterns, scientists can determine not only what an exoplanet's atmosphere is made of, but whether it might support life. This is more than astronomy. It's space forensics. And Proxima B has become the prime suspect in our search for a second Earth. It orbits in the so-called habitable zone, also known as the Goldilocks zone, where conditions might be just right for liquid water to exist. Not too hot. Not too cold. Imagine standing on a shoreline on Proxima B, watching alien waves lap against the rocks under a red-tinged sky. Imagine rainstorms, wind, perhaps even the scent of unfamiliar flora in the air. These are not science fiction fantasies. They are hypotheses, questions we now have the tools to test. But this world is not without Proxima B, Earth's mysterious twin or cosmic trickster. Since its discovery in 2016, Proxima B has stood like a Shakespearean character in the theater of the cosmos, mysterious, paradoxical, and profoundly compelling. It's a planet that tempts us with familiarity but then throws us into the unknown. A world that could be our cosmic reflection or a carefully veiled illusion. Let's begin with time. One day on Proxima B lasts about 11 Earth days. Yes, you heard that right. Imagine standing on its surface and watching the sun take more than a week to climb across the sky. Sunrises that stretch like liquid gold across the horizon, refusing to rush, refusing to yield. Sunsets that linger for days, casting shadows that slowly dance over mountain ranges and alien valleys. At first, it might sound poetic, an eternal golden hour. But this drawn-out cycle has profound biological and environmental implications. Would plants grow under such prolonged exposure? Would water evaporate differently? How would animals, if they exist, adapt to a light cycle that rewrites the rules of circadian rhythm? For humans, it would demand a complete recalibration of life. Imagine having to sleep in cycles independent of the sky. Imagine managing food, energy, and social rhythms not by day and night but by arbitrary artificial clocks. Even simple tasks like agriculture would have to be reinvented. It's Earth-like, yes, but just enough to unsettle the familiar. And then came the moment that made headlines around the world: a signal. From the direction of Proxima B, not random noise. Not static. But a highly structured electromagnetic signal that defied easy classification. It was brief. It was complex. It resembled what some experts call a techno-signature, a potential indication of technology not born on Earth. For a fleeting instant, humanity stood united in curiosity and awe. Was this it? Were we finally hearing from someone or something else out there? Scientists and skeptics rushed to examine the data. Some believed it could be a misinterpreted natural phenomenon. Others weren't so sure. And then the silence. The signal never repeated. It vanished into the void, leaving behind a cloud of theories, debates, and what-ifs. Was it a cosmic coincidence? A fleeting anomaly? Or was it a deliberate whisper from a civilization far older and more advanced than ours, testing whether we're listening? In the absence of certainty, speculation flourished. Because in science, even a mystery is a form of progress. But we didn't stop there. We advanced our approach, evolved our search strategy. At Harvard and other institutions, a new frontier opened. Researchers began to treat the James Webb Space Telescope not just as a scientific instrument, but as a searchlight for the unseen. They developed techniques to scan for artificial light, the telltale glow of civilizations on alien planets. The idea is simple, but revolutionary. If an advanced society exists on a distant planet, it might light up its cities just as we do. Even the faint glow of a distant metropolis could, in theory, be detected. Imagine gazing through the cosmic dark and seeing a city skyline, not made of glass and steel, but something entirely alien shimmering in the night from light years away. Imagine spotting artificial luminescence on the night side of Proxima B like a cosmic beacon, a silent but undeniable sign. We are not alone. These light sources wouldn't flicker randomly. They would follow patterns. Grids. Geometric distributions. Evidence of engineering. Of thought. Of intent. If discovered, it would be the most profound shift in human history. Not just contact, but confirmation intelligent life exists elsewhere, and it too has learned to manipulate light against the dark. And with the tools now at our disposal, that future feels increasingly possible. Milky Way final reflection. So what are we really looking at when we peer at Proxima B? We're not just looking at a planet. We're looking at a mirror, a reflection of our hopes, fears, and curiosity. A question framed in starlight: is Earth unique? Or are there others, waiting, evolving, dreaming like us? The James Webb Telescope is revolutionizing our understanding of what's out there. Every spectrum of light it decodes brings us one step closer to turning imagination into confirmation. We are not merely observers anymore. We are interrogators of the cosmos, asking deeper, bolder questions, and refusing to settle for silence. Proxima B might be Earth's twin. Or it might be a decoy in the grand game of universal evolution. But one thing is certain: its story is far from over. With every orbit, every signal, every pixel of data, the curtain lifts a little higher. The cosmos reveals a little more. So keep looking up. Keep listening. Because the next message may already be on its way. If this cosmic journey resonated with you, don't forget to like, subscribe, and share your thoughts in the comments. The universe is vast, but understanding it starts with curiosity. And who knows? One day, Proxima